Thanks everyone to be here. The very last slot of the conference. So yeah, I appreciate that. My name is Álvaro Sánchez, and I promise you two things. You will learn something new, and you will have fun. So let's try. Slides are available on speaker deck if you want to take a picture. There is not only this presentation, but a few others. So, little bit about me. I'm coming from Madrid, from Spain, as you can tell from my perfect accent. I'm a developer since forever. I'm a Java developer since forever. I always used the Java stack. For a while, I used JavaScript and a few other things, but I'm not really a front-end person. At the moment, I'm working at Oracle on Micronaut. Since the inception of the framework, there's few areas of the framework that I work on. The part of Oracle that I work for is Oracle Labs, which is a research and development organization of Oracle, and it is the same organization where GraalVM belongs to. You probably have heard of GraalVM before. Yeah, I'm not a developer advocate myself. I'm just a committer on the project, but I enjoy going to conferences like this one. It is my first time at Øredev. Hope it's not the last one. Yep, at the personal level, let me tell you that I'm a runner. Yes, don't be surprised. I'm a runner. I run a lot. And I run very fast because I run containers, I run applications, and I run them very fast. I assume all of you are Java developers, right? Raise your hand if you're a Java developer. Who's not a Java developer? Wow, quite a few. Okay. What are you guys using, like .NET or JavaScript or? Yep, Python. Yep. Yeah, this is mostly focused on Java, but the general idea about test containers is okay for all of you. For those that are using Java, who is using Spring Boot, for example? Quite a few. Thank you very much. You can leave the room now. Now it's a joke. Spring is a wonderful framework. I actually spent 1 year working for VMware, which is or used to be a fantastic company. Who's using Quarkus? Okay, we have one hand here. And who's using Micronaut? Yep, cool. I told you that I have been working on Micronaut since the beginning of the project. We started this project in the year 2017. The team creating Micronaut is the same team that created Grails. I don't know if you heard about Grails framework before. So yeah, we spent more than 10 years creating Grails, and we learned we learned quite a few lessons about how a framework should behave. And that's why we started from scratch to create Micronaut. Let me tell you one story. It's a true story. At the beginning, Micronaut wasn't called Micronaut. It was the code name was Particle, but Particle was I don't know, the domain name was not available, was a trademark issue, whatever. So we had to choose a new name for the framework, and we ran a poll internally across the team to choose a new name. And I proposed something that wasn't selected. I still don't get why. My proposal was to name the framework Summer, because we all know that summer is better than spring. Okay, that's enough. Let's get into the actual content. Who's seen this picture before? Who's in agreement with this picture in year 2024? I mean, you can still agree. Why not? It's by Martin Fowler, so I'm no one to disagree with him. For those who've never seen that before, this is the so-called test pyramid, and it's based on the idea of the amount of each type of test that you should write in your applications. So this idea tells you that you should write, the majority of your tests should be unit tests, because they are fast, they're very small, they're very fine-grained, and you're testing like a single method, a single class, etc. And you can have lots of them, but obviously it's not enough to test a single method from a single class, right? You need to test more than that. So that's why things start getting complicated, and you need to use something like Mockito to mock collaborators and whatnot. Then we have integration tests. In an integration test, you test your application, including the services that it is for running, like for example, the database or message queue or cache server. And they are slower because you need to provision those things, right? You need to provision somehow. You need to get a database for your application to be tested. So what we have done in the past typically is to use in-memory services for this kind of testing, right? So in memory, like H2 for testing, and then finally, the less amount of tests that you should write is or are end-to-end tests. And those are very terribly complicated to set up because you not only need to deploy your application, but also any other application that is needed to test it. You know, if you're writing microservices, maybe your microservice is one part, but if you're testing a UI that is interacting with multiple microservices, you will have to deploy them all. That's difficult. This is based on the idea that integration testing is difficult and is costly. And I don't think that's true anymore. There is also another alternative approach coined by Spotify, which is called the test honeycomb. And in this approach, what they tell is that what you should be really writing is integration tests. Mostly, right? And then at the bottom of the chart, you have what could be considered like unit tests or implementation details tests, right? You can still write them, right? But you should really focus on writing integration tests. And then the integrated test would be or could be considered like the end-to-end test. So you test not only your application, but also integrated with the whole ecosystem. This is for you to think about which approach you think is best. But I want you to think on the idea that this approach, this was created in the year 2011, right? So it's a lot since then, right? So we didn't even have a Spring Boot, for example, right? So the technology has changed a lot since then. So talking about the specific libraries that you can use for each part, we have, for example, for unit testing, you have JUnit and Mockito. I think we all use that, right? Is anyone using anything other than JUnit? Obviously, people not using Java will use something else, I expect. But people using Java, is anyone using Spock, for example? Yeah, that's good. Cucumber, for example. Yeah. For end-to-end testing, if your deliverable is an interface, then you will use something like Selenium to run a browser-based test. But if you deliver is a REST API, then you can use a REST client like Rest Assured to test your API, right? And then for integration testing, like I told you, we typically used in-memory databases for local development. And then we all have like different environments like staging or pre-production or whatever you call it, where you had the real database. And this was always a problem because like for example, if you are using Oracle DB, which is the best database in the world, and you're writing PL SQL, how do you test that with H2, right? It's impossible. You need an Oracle database, right? Or it could be the same situation with Postgres, right? So this is precisely where test containers fits. Who's using test containers already? You never heard about test containers before. Okay, quite a few hands. You're in the right place. So let me tell you, the test container is a library supporting multiple languages to manage Docker containers, or basically to manage services that your application needs and that they are provisioned with Docker containers. If you need a database, there are database containers that you can use, and these containers will take care of provisioning those container instances for your tests. It basically integrates with your testing library to automatically provision those containers for you. Well, not automatically, but almost. Like I said, they support multiple languages. This originated from the Java ecosystem, but they are now expanding into multiple languages. In the case of test containers, Java, which is the original integration, they support JUnit and Spock, and you will find first-class support in Spring, Quarkus, and Micronaut. And by first-class support, I mean specific ways of using test containers, right? I will show you both. I will show you like a vanilla use of test containers and then how do we use it as Micronauts. There are official modules for almost everything. Databases, cache servers, for message-driven things like, I don't know, Kafka, RabbitMQ, even cloud emulation like AWS Local Stack, you name it. And this is only official modules. But there's also, well, I think I have here. What this container will do is basically manage the container lifecycle, right? So there is Java API that you can use in your test to specify that you want, for example, a Postgres container. And they will start it and stop it with, for example, in the case of JUnit with a JUnit extension. So they will hook into the JUnit lifecycle and start and stop the container in the appropriate moment. It allows you to customize almost everything about this container that you're running, right? It has a Java API to customize the network configuration. You can run commands in the started container, even copy files into it. And if there is no email, so official modules are modules that are like already prepared. Like for example, a Postgres container is a class with literally that name, Postgres container, that is already pre-configured to understand that the container that is running is Postgres, and Disable is already pre-configured to watch or to basically to listen or to wait, to be more specific, to wait for Postgres to be ready. Because that's obviously something you need in your test, right? Your test can't start if the database is not ready, right? And test containers will handle that, right? So official module means that everything is pre-configured, you don't have to do anything else. But if there's any other thing that there is no official module for, you can use the generic container, and then you can configure yourself this weight strategy, or which ports are you exposing, things like that, right? I will show that in a demo. But even if there's no Docker image built already for what you need to test or integrate with, like imagine you have two services, they need to interact with each other, and you don't have yet a Docker image built for the other service. You can point test containers to a Docker file, and it will build the image on the fly, which is very handy. And it has a feature called reusable containers. So normally when you run from Maven or Gradle, you run the task, it will start and stop the container. But with a reusable container, containers are kept running for a while, which will save you time if you're running your test multiple times. It has a companion application called Testcontainers Desktop. This is really handy because it allows you to use to choose the container engine. For those using Mac, you know that you have basically to pay for Docker Desktop, right? That's the official runtime. There's other alternatives, but fortunately for you, Testcontainers Desktop ships with an embedded runtime that is mostly okay for all your testing, right? So this embedded runtime is really fast. You don't need to use anything like Docker Desktop or Rancher or anything like that. It will just work. But if you have any other engine installed locally, like for example Stack, which I recommend for Mac users, then you can use it. And it has a few other things, like for example, you can from the desktop app, you can see the logs of a running container, and for example, you can attach a terminal like a shell into running container. But obviously, for this to happen, the container has to be running, and if you're running a test, those containers are going to be really ephemeral. So it has another feature, which is a freeze container shutdown, which means that it will keep containers running for you after the tests have run, which is useful if you need to inspect the state of a container, or I don't know, you want to run PLSQL client locally into the container, you can do that after your test. So for debugging, it's very useful. And finally, they have this service in the cloud, which is Testcontainer Cloud. This is a paid service, so you basically have to pay. Testcontainers is an open source library itself. They have one company behind it called Atomic Jar, and now Atomic Jar has been acquired by Docker itself. Well, they get revenue basically from this service. The idea with Test Container Clouds is that your container instances are not run locally in any engine locally, but are run in their cloud, right? And this could be a great idea. For example, if you're using Mac and you're using the new Apple Silicon Mac and need to run an Intel-based container locally, you can use, for example, something like Colima, which has Intel emulation, and have a miserable experience. Or you can run them in Testcontainers Cloud and be happy about it. So I think that's a use case that is worth exploring. Okay, so let me show you the first demo. This is a vanilla Java project with no framework whatsoever. And I have two classes. I have this interface cache with a couple of operations. And then I have one implementation that is using Redis. This implementation is taking the Redis client as a constructor parameter. So obviously, someone has to build this guy and pass it to us. And then the implementation of the operations are simply using the Redis client. Now, if we look at the test, this is how you use test containers in any Java project, right? Without framework support. There is this annotation that they use to hook into the Unit lifecycle, and then you annotate your containers with the add container annotation. In this case, there is no official module for Redis, but you don't need it because it's as simple as using this generic container class. You pass it the image name, and you tell which is the spouse port that you're interested into. This is the default port of Redis, but this will be exposed on a random port, which you need to know in order to build this Redis client called Redis. You get this is going to be normally localhost, but for example, if you use Rancher, this could be an IP address. So you don't care about the value. You call getHost, and you will get the right value for it. And in this case, you're getting the mapped port where this original post has been exposed, right? This is going to be the random value, right? And well, this is testing that the service is working as expected. So we can run this directly from IDEA. And it's really fast. Also, this generic container has a default wait strategy. They will wait for this post port to be listening, right? Which is a strategy, is a good default wait strategy because that will work with most of the things. There may be cases where you need to specify a custom wait strategy. Like for example, there is a log message wait strategy where you wait not only for the port to be listening, but maybe you need to wait for a specific message in the logs in the container to mark it as ready. And only then your test will start. So far, so good. One question? The container what? The annotation? This is the annotation they use to also to hook into the Unit lifecycle. It's kind of internal to test containers, so it belongs to the test container JUnit integration. For other languages and other integrations, for example, there is the test containers Go integration, which is widely used, but I'll be honest, I have zero idea about that. So that's it. Any other question? No, not in this way. I have one example later. All right. I open a parenthesis. 30 seconds of Micronaut introduction. Who's never heard about Micronaut before? Okay. There's three ideas I would like you to get about Micronaut. One is that it's a modern open source Java framework. If we take into consideration the Java framework history and landscape, we have the Spring framework was created in the year 2001 or 2. Then later we had the Spring Boot in the year 2014, I think. But We are no longer creating Word files or ER files or having EGPs or anything like that. So the industry has changed. We are no longer, deploying applications to an application server. Like the application server is kind of embedded into the application, right? We found very difficult, because I told you we're coming from the Grails framework, we found it very difficult to adapt to this new microservices era if we had a framework that would take a lot of to start up. It was like really pleasant to work with. So that's why we decided to start from scratch and create something new, but thinking of the type of applications that are created today, and thinking with the cloud in mind. There wasn't any cloud in the year 2000. And it's open source, by the way, Apache 2 license. It's a generic purpose framework. You can use it for anything that you want. All application types. People typically use it to create REST APIs, but you can create, for example, a command line application. You can create a serverless function and deploy it to AWS Lambda or OCI functions. You can create a headless Kafka consumer and producer with no HTTP server whatsoever, just the Kafka listener, and it will just work. So you name it. And the third idea is performance. Performance for us is kind of almost an obsession. And for us, performance is not only throughput and peak performance, which is also important. There is a benchmark out there called the Tech and Power benchmark. I don't know if you heard about it. It's a kind of independent benchmark, which is benchmarking all the things in the world, not only Java, but any technology framework. They have hundreds of benchmarks running then. So if you filter out by Java, for example, you will see benchmark from the most popular Java frameworks, and Micronaut is very competitive in there. That's not the performance I'm talking about. The performance I'm talking about is to metrics that will dramatically change your developer experience, and those are startup time and memory consumption. You guys know how long are your applications taking to start locally? Who has an application that starts in less than 1 second locally? Less than 1 second, okay. You're using Quarkus, you said. You're using Quarkus? No? .NET, okay. Less than 5 seconds. We have some hands. Less than 30 seconds. Yeah, the majority of them. Does anyone have an application that takes more than a minute to start locally? We have quite a few hands. When you have an application that takes 1 minute or more, or even 30 seconds, or even 10 seconds to start, you won't even think about running an integration test, right? It is there's no way you're going to do that. But on the other hand, mocking is not for free. You need to mock things, right? So that's why we believe a really fast startup experience will change the way you think about testing. How do we do that? We basically are hooking into the Java compilation. We are literally called by the Java C compiler, right? If you think about, for example, in Spring, add autowired or add transactional. Let's talk about add transactional. Who knows what's happening under the covers when you add transactional to a method in Spring? A lot of things happens. So first of all, for Spring to find it, they will scan your class path to find the notation, and they will use reflection for that. Reflection is a very slow API. It's getting faster with every new Java release, but it is still somewhat slow. And because it's slow, what happens is that frameworks that use reflection, frameworks and libraries that use reflection, they have a reflective cache in memory so that you're not querying over and over again which are the annotations of a class, which are the members of an annotation. Is this method having this annotation or not, right? They have a cache in memory, but you will likely not only use Spring, but for example, Hibernate, who's using Hibernate here. Yes, so Hibernate will have their own cache, right? Because they have their own annotations. So this means that memory will skyrocket, right? And also CPU consumption or CPU utilization will skyrocket as well, because we haven't stopped there. So remember, you have a method with that transactional. So what they have to do is they have on the fly generate bytecode. On the fly, they will generate while your application is starting up. I want to keep you thinking on this. They will generate a subclass of your class with basically an overwritten method, which is having this logic to open the transaction and commit the transaction after that, right? And they do that by generating bytecode at runtime, and this takes time. No wonder this takes time, right? And the startup time and the memory consumption with this runtime approach has no limit. So it will grow and grow and grow. The more beans you have, the more source code you have, the more it will take to start up, and the more memory it will consume. Surprisingly, there is a standard Java feature that almost no one thought about using for annotations. And this is called, Java annotations, by the way, were introduced in Java 5 or 1.5. So that was, 20 years ago, something like that? Even more. But in Java 6, in year 2006, it was introduced a Java Annotation Processing API, which is this compiler hook facility that we are using to basically process annotations during compilation, right? We are not the first framework or library to use annotation processing API. There is the first one, I think, to do it seriously was Dagger from Google, which is a tiny dependency injection library that became popular for Android applications. And also Lombok. Who's using Lombok here? You can also leave the room because Lombok is a bit evil. It's an annotation processor, but what they do when they process the annotations is different than what we do. We can discuss this later. So what do we do during compilation? We process your source code during compilation, and we generate all the framework infrastructure during compilation, right? And most of the time, we will generate bytecode. But it's bytecode generated during compilation, so you don't have to worry about that at runtime. So that at runtime, there's no reflection, there's no proxy generation, and no dynamic class loading, and we don't scan your class path, which is really important. There are a few use cases where we generate source code, but the majority of the times we are generating bytecode, which is already compiled. It doesn't require any other compilation round. And that's it. I close parentheses. This was the Micronaut introduction. If anyone wants to learn more about it, feel free to ask me after the session. Now, the integration with test containers that we have is called Test Resources, and it's expanding on the idea of test containers because I told you test containers. I mean, the name is spot on because it's for testing and it's using containers, right? So, I mean, it's a brilliant name, right? But you may need to test. Imagine that you, for example, you're given, I don't know, a legacy binary application that you need to run. It will, I don't know, write an XML in the file system, right? That sometimes happens. You need to do those sort of things, right? So it would be great if we could use something that would provision this binary for you, would run it for you before your application is running, right? And there is also test containers is not enough because, okay, if I run a test, I have this test container, but what if I want to run my application locally, right? You will not have test containers in your production class path, right? To run the application locally. That's a mistake. You shouldn't do that. So it would be great if there was a way to have test containers also for running the application locally. Only locally, not in any other environment. So this is what Micronaut Test Resources is doing, is going farther in the integration with test containers. So you can use basically anything that test container supports. But even more, like I said, if you have a binary that you need to integrate with, you can use it. And it's zero configuration, zero integration with test containers. You will see that later. This is the explanation of how it works, but let me show it because I think it's worth seeing it live. In here, I have a simple Micronaut application. It's not a hello world, but I mean, it's not a bank or a government application either. So, but it has few things, like for example, has one entity using JPA annotations. I'm using Micronaut Data JPA, which is Micronaut Data JDBC, which is a lightweight implementation, and well, I have a controller, repository, right? In Micronaut, you will find the same terms and building blocks than in other frameworks like Spring, so that you feel like at home. And yeah, so how do we test this? This is my test for the controller. So I'm not testing. You could think like an integration test would be for the repository, right? But I'm testing the controller, so I'm testing the application from outside. This could be thought as an end-to-end test, okay? So in this case, I need to run my application with all that it needs. In this case, is a database. I need to grab an HTTP client. I need to send a request to my application and then make an assertion on the response. Yeah, so far so good. Blink your eyes if it's going well. So a few things we have here. Micronaut test annotation will take care of running your application on a random port and will make this test class part of the application context so that you can inject any. What's the audio? Okay. Did it run out of time? No, not yet. Can you hear me? I can. Yeah, well, you can fix it. Yes, will do. So basically, you can inject anything, right? In this case, I could, for example, if I were to write an integration test, I could inject the repository, make a call to the repository, and then test it. But in this case, this is the repository. There's nothing I'm going to test about it. I will be testing the framework. You're not interested in doing that. So I think it's more interesting to test the controller. The few other goodies in here, like for example, we have mapping annotations, which are kind of a replacement for map struct. The idea we have is that we want to reduce the needs that you guys have to use libraries like MapStrap and especially Lombok. Like for example, we also have at Builder, which is built in. And the idea is that if I were to give you an advice today, it wouldn't even to use Micronaut or test containers. My single advice today would be that you should strive to reduce the number of dependencies of your application. And you will live much better if you do that, right? Upgrades to newer versions will be much easier. You will have less CVs and whatnot. But yeah, going back to the test, we want a client. So if we look at the controller, it's implementing a Java interface, right? This is a Java interface that I'm using to declare my endpoint operations. You see that? Yeah. I have 3 operations in here. There's 2 implementations of this interface. One is the server, or actually the controller, right? And the controller is using repository and mapper to do its job. Normally, you will have like a service layer, but I thought it was too much for a demo. The repository is working with entities. The controller is working. The outside world is working with DTOs. So then the mapper is basically mapping between entity and DTO. The other implementation of the interface is the client. And this is literally what it takes for you to get a high-level HTTP client for your controller. And it's implementing the same Java interface. So I could be using Micronaut's low-level HTTP client, which is similar to Spring REST client or REST template, and I could be sending an exchange request. Send them a body. Send them a body and then parse the response. But wouldn't it be great if I could use DTOs? Like my high-level classes, right? It's all parsed and used. So this is what the test is doing. Let me run this very quickly. What I will do first is to first of all run Maven test, and let's see what's happened. I think there is like a break now, so maybe we're going to stay for a few seconds. So this is a really functional test, end-to-end test. And because I knew you would say like it's impossible that it's running everything so fast, I've included trace logging for the SQL queries and for the JSON requests and responses, right? And we have a container provision here, right? Now, if we look at the test, let me search for test containers. There's no test containers classes at all. This is automatic. This is 0 configuration. We have a container, and we didn't even have to bother to specify it. I will explain why. Now, if I want to run this from the terminal, from the IDE, what I do is I will start a daemon application called Test Resources Service. And then I come back here and run this from the IDE. 200 milliseconds to run an end-to-end test, including creating a container. Well, not creating a container. The container was created before. This is running the application on a random port, creating a connection pool, creating the schema, inserting some data, and actually running the test. Right? I think this is impressive. This is the development experience that I'm talking about all the time, and I think this is what will change your life locally. So now, how or why the hell is this working? Since I didn't specify anything, so let me go back to this part of the presentation. It's a bit tiny, but I can use the pointer for this. So when we run Maven test, what happens is that we start what I did manually before. We start a daemon service. It's called the Test Resources Service. This is a small daemon application where we keep test containers dependencies. And this is responsible for starting and stopping containers for you, right? Then Maven will basically start the testing, the application will start up, beans will be created, and there is one bean in your application that requires some configuration properties. The data source bean needs the data source URL, the username and the password. And I have purposely omitted those values for test and development, right? I didn't provide any value. So in that case, what happens is that the Micronaut application has something called the Test Resources client, and the client will ask the server, hey, can you resolve this property? And it will say, yes, I can resolve this property by starting a container, right? And reading and reading the random port where the application is exposed. So I will give that back to you. So that's basically the JDBC URL that you need to be using. The username and the password could be random as well. So the data source bin will be created with those values, and then the test will be executed. And after that, we stopped the test resources service, which will make the container to be stopped. Right? This is how it works. Now, if you think about how do you use it in Spring, for example, what happened in Spring is that in Spring you do have test container dependencies on your testing class path. And this is a problem because when you have test containers on your testing class path, it means that your production class path and your testing class path are different, right? Why is this problematic? Because, well, test containers has dependencies. They have, for example, they have Jackson. So you could run into class path issues if the Jackson application you're testing during the test is different than the one that you have in production, right? So that's why we prefer to separate class path, and you have not at all any test container dependency on your class path. So far, so good? Yes? Is there any question